Welcome to lecture series on data structures. In today's lecture series, let us discuss about breadth first traversal and graph data structure. So in the previous lectures, we have discussed about what is tree ADT and what are the various terminologies in tree ADT. We have seen about breadth first binary search tree and AVL trees. So today, let us discuss what a graph data structure is about. So a graph is considered as nonlinear data structure. Any graph, it consists of vertices and edges. So like how we have represented tree using array and linked list, we can represent graph using a adjacency list and adjacency matrix representation. We can also represent graph using incidence matrix. So this graph can be classified as cyclic or acyclic graph, weighted or unweighted graph, and directed or undirected graph. Uh, so if graph forms a cycle, it is called a cyclic graph. If there is no loop in the graph, then it is called as acyclic graph. And if each edge in the graph is associated with the cost, it is called as weighted graph. And if there is no cost, it is unweighted graph. If edge points to a specific direction, we call it as directed graph. And it does not point to any specific direction, it is undirected graph. So these are the various concepts we have seen in our previous lecture. Today, let us discuss why we require breadth first search process and what are the various traversal levels in breadth first search. We will also see how VFS is implemented using Q, and at the end, let us discuss about the various applications of breadth first search. So before going into the process of breadth first search, let us discuss why BFS is required. Consider some scenarios such as you are in an emergency evacuation process, and if you want to spread message or if you want to disseminate a message from one person to another, and if you want to find the shortest route in a Google map, if you want to search for someone in each floor, in all these cases, you will perform the search in a level by level manner. So this is where breadth first search is applied. If you want to search or traverse a graph in level by level manner, or if you want to find the connected components in a graph, and in case of unweighted graph, if you want to find the shortest path, and if you want to check for bipartite graphs, in all these cases, breadth first search is applied. So this is a working of breadth first search algorithm. So it contains hierarchical layer of nodes that can be explored, and it uses queue data structure for performing level order traversal. It explores the immediate nodes first before exploring the nodes at the next level. So this is one of the core methodology using graph traversal process. So this is the working of breadth first search. So look at the unweighted graph which is given here. Initially, you will visit the vertex A. So when you visit the vertex A, you will mark all the adjacent vertices of A. So now here the adjacent vertices of A are B and C, which is entered into the queue. Then this vertex A is printed in the output. So now the element in the queue, which is B, is visited. Adjacent vertex of B is D, which is pushed into the queue. Then you can remove B from the queue and write it in the output. Now we have C in the front of the queue. So C is visited. When you are visiting C, the adjacent vertex of C, which is E, is also entered in the queue. So likewise, this process is continued until you visit all the vertices. So now the adjacent vertex of D is F. So F is entered into the queue and D is removed from the queue and it is written in the output. And at last, we have E in the front of the queue. Adjacent vertex of E is F. So F is already in the queue. So you can remove E from the queue and write it in the output. At last, we have F. And there are no adjacent vertices of F which is left unvisited. So you can remove F from the queue and you can write it in the output. So this is the step-by-step process of breadth first traversal. Initially, you will create an empty queue and you create a visited set. So each time you visit an vertex, you will add that particular vertex to the queue and mark it as visited, which marks the beginning of traversal process. So that the node or the vertex in the front of the queue is removed and it is processed. So by means of processing, it refers to printing the element in the vertex or performing other required operation on the vertex. So for each unvisited neighbor of the current node, you will mark it as visited and you will add it back for further processing. This process continues until the queue is empty and all the vertices are visited. So here, look at this graph. So initially, at level 1, we have only one vertex, which is A. So that is visited first. And in next level, we have B and C. And in the third level, we have D and E. And in the fourth level, we have E, F, G, and H. And in fifth level, I, J, K. And in the last level, we have last level 6, we have L. So the vertices are visited in level by level manner. So initially, vertex at level 1 is visited, and next vertex at level 2 will be visited, and so on until vertex at the last level is visited. So this is the hierarchy of BFS algorithm. It is one of the efficient graph exploration algorithm, and it is used in determining the connection between networks. It is also used for finding the shortest path in a graph. It is also employed in various problem-solving scenarios for obtaining the efficient solution. And it is one of the most basic graph traversal technique that is used. Here are few of the applications of breadth first search. It is used in social network analysis like LinkedIn. It is used in Google Map for finding path and navigation purpose. And in case of search engine, BFS is employed for web crawling and indexing. And so far, to conclude, we have discussed why we need a BFS algorithm and what is the process behind the working of breadth first search and what is the data structure used. We have seen the applications of breadth first traversal, and we have also seen the working of algorithm. So hope you have understood. So now look at the assessment. The first question is the data structure which is used in standard implementation of BFS, which is Q. And next, if a person wants to visit the places, he uses breadth first search algorithm. So these are some of the references. Thanks for watching. We will discuss some other topic in the next lecture video.